Hey guys, it's Mr. L here coming at you with another video. In this video, we're going to cover laboratory safety. The main topics in this video are going to be personal protective equipment, the GHS pictograms, which are the universal global harmonized system for hazard pictograms, which all bottles are typically labeled, the hazard diamonds, and the do's and don'ts in the lab. So let's get started. First thing that we're going to do is we're going to need to change into our personal protective equipment. So let me just do that right now. Oh, there we go. That was super easy. So what we're going to do now is go over the typical PPE that you would wear in the lab. The first thing that we're going to talk about are these guys right here, your goggles. I would say these are one of the most important articles that you're going to wear in the lab. The main reason for this is if you spill a chemical on yourself, you can regrow your skin. If you break a bone, you can regrow your bones, but your eyes, they're not going to regrow. Right? So your eye protection is essential. And some things you may notice about my goggles is they completely wrap around. So if you have a splashing event, it's going to completely protect your eyes. You don't have anything that's going to get in or around your eyes. So this is extremely important. The next thing we have here are my gloves. There's all different kinds of gloves. You've got rubber gloves, latex gloves. These are nitrile gloves. Nitrile gloves are what you're going to most typically see in the lab. And the reason for this is they protect against a lot of different solvents or things that will be able to go through your skin, as well as there's less allergen effects from nitrile gloves. But obviously, if you have an allergy to nitrile or latex, make sure you let your instructor know, or if you're just somebody on YouTube trying to look for PPE, make sure you select the correct PPE for your skin type. All right, next thing we got here is a lab coat. You're going to want something over an article of clothing that you probably don't care that much about. If it gets caught on fire, if you spill something on it, it stains it, it gets burnt up, torn up. You want some not so nice articles underneath. And then on top of that, you're going to want to protect yourself. If you're working in industry, organic lab, or anything like that, you're going to want a full lab coat. But for general chemistry and AP chemistry, an apron should be sufficient, or anything that will give you some decent coverage from splashing towards your chest in your lap. That's going to be where most of the spilling occurs. I like sleeves just because you never know what's going to be on the bench, so I enjoy having the sleeves here. All right, so now let's go down here and look a little further. All right, guys, so what you notice down here is I have long pants. You shouldn't be showing up to the lab with shorts, skirts, or anything that's going to expose your legs. You want to cover as much of your body from potential hazards as you can. So I always wear long pants to the lab. The next thing you know are my stunner shoes. Why these are stunner shoes is they completely cover my feet. I'm not wearing flip-flops. I'm not wearing Crocs. My toes are completely covered to protect from any splashes, as well as people drop stuff on the floor, including glass. So you don't want to get shards of broken glass into your toes. So it's super important that you show up with closed-toe shoes. All right, next thing that we're going to talk about is keeping your workspace clean. You can see we don't have much out here. And when I do like to work in the lab, I only like the minimal resources necessary to do whatever part of the experiment is necessary. So what you're going to want to do is always keep your workplace free of any obstacles. You don't want to quickly move your hand because something sparked up and you smash over a graduated cylinder or something like that. If you have any spills, you're going to want to tell the instructor about what you spilled. If it's water or something, you can clean that up yourself. But if it's a toxic compound and the instructor's told you beforehand that that thing's toxic, make sure you alert that instructor so they can tell you how to clean it up, or they may need to clean it up themselves. The last major personal protective equipment that we're going to look at are these guys here called the Fume Hood. The Fume Hoods are here to protect you from breathing in toxic fumes. So if you're heating something that's volatile, some organic compound, or something that you just don't want to breathe in, you're going to want to work underneath this thing called the Fume Hood. And the way the Fume Hood works is you've got these sashes. You can lift the sash up and you stick your hands up under there, but the plate is going to protect you from all those fumes, and all those fumes are going to be brought right out of the room so that you're good to go. So let's talk about some of the do's and don'ts that you're going to do in the lab. The things that you do not want to do in the lab, I repeat, do not want to do in the lab, are ingest anything. You don't want to eat in the lab. You don't want to have water in the lab. You want no drinks in the lab. You want no chewing gum in the lab. Nothing that's going to potentially get in your mouth you should have in your lab. So you're typically going to want to keep those out of the lab. Don't bring them in. Or if you're a high school student, you have to bring your backpack. Make sure you're tucking those underneath the lab bench. Make sure that water bottle is sealed up tight, tucked in your backpack so there's no potential for any chemical contamination. The next thing you're going to want to not do is carry bottles around the room if that's not necessary. So an example of this is, here we go. We've got this extremely toxic compound here. We don't want to be carrying it around the room, potentially dropping it all over the ground, dropping it on people, exposing them to people. So you want to minimize the movement of any articles. If you absolutely have to move bottles, which sometimes are necessary, you're going to want to use two hands. You're going to want to grip the side and underneath, and you're going to carry it just like this, with one hand underneath and one hand right on the side there, and try and get it down to the table as soon as possible. And you're going to want to place that guy right in the middle of the table like so. Oh wow, super safe, right here in the middle of the table. Dun, 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 dun. So the next thing we're going to address is not pipetting by mouth. So in another video, we're going to go over lab equipment, but some of you may be familiar with a pipette. It's a long tube that transfers liquids or solutions to another container. So back in the day, older guys, they used to literally put their mouth on the pipette and suck the liquid up part of the way and then put it down. We do not do this anymore. Once again, nothing should be going in your mouth. It's kind of weird that people used to do that, particularly with bacterial samples, which kind of makes no sense to me. But please, no mouth pipetting in the lab. The next thing that we're going to talk about is once you open a bottle and you take a sample out of that bottle, it is now considered contaminated. So once something leaves that bottle, it never goes back in the bottle. This is one of the things I frequently see my students violate. It's so easily to just, oh, there's such a little bit left, let me just put it back in the bottle. But you're potentially contaminating now the rest of the bottle, and then all future experiments could have that contamination, so you don't want to do that to the bottle. Whatever comes out of the bottle stays out of the bottle. So what that means is make sure you do calculations, make sure you read your pre-lab so you know what's going to be taken out of the bottle. And that way you know exactly what needs to be taken out and you won't have any leftovers. Make sure you guys do your research and your math before you start opening bottles in the lab. The last thing that you're going to not want to do is just do stuff before the instructor tells you to do it. The instructor's been trained. They have many years of experience. They went to school, spent all this money to get this experience. So make sure you just listen to them at the beginning. I always like to coach my students right before the lab on the potential hazards, how to get rid of stuff, all the toxic waste, and any other things that they need to be aware of. I like to tell them what's going to be flammable, what's going to be toxic not to get on their skin. So just make sure you're paying attention to your instructor because they're there to help you out. All right, so now let's talk about the things you do want to do. Like I already mentioned, you want to keep your workspace as clean as possible. Only the minimal stuff to do the labs is what you really want to have out there on the lab bench. You always, again, you want to listen to your instructor. If something breaks, which it happens, and a lot of times it's not even your fault. When you're heating things repeatedly like glassware, they're going to form cracks. And once you see those cracks, you're going to want to get rid of the glassware. So there's a lot of different waste types in the chemistry lab, and let's go look at some of those waste types. So one thing that I always do in the lab before I start working with stuff is check your glassware. And in this case, if you can see here, there's a crack on the speaker. So you want to inspect all your equipment to make sure it's not going to shatter once you heat it. And so what we're going to need to do with the speaker is dispose of it properly. So we're going to put that in one of our wastes here. So we keep our waste down here. So our broken glass is going to go here in the broken glass waste. Most labs are going to have broken glass waste in the lab. So you just take your cracked glass and drop it right there in the broken glass waste. You can see here we've got some other waste buckets. If you spill a chemical and your instructor directs you, or they're going to clean it up for you depending on the compound, you're going to look here at these contaminated towels. You don't want to put the towels in the trash for the janitor to get sick because they may not know what's going to happen in the lab. So you want to make sure that you're putting the contaminated towels in the perfect waste for it so that you're not getting people sick. We also share this lab with our biology teacher, and so any potential biohazardous substance, including blood, your own blood, that they could harbor bloodborne pathogens. So we're going to put all of those bloodborne pathogens in the biohazard waste. If you're working with bacteria cultures, and I'm trained as a biochemist, so I worked with a lot of E. coli, Plasmodium falciparum, as well as Mycobacterium tuberculosis. All those samples, they need to be housed in the biohazard waste so that they can be autoclaved at the end of the day. All right, so let's look here at some other waste here. So you're going to want to separate your waste depending on what the waste is. We've got all sorts of different buckets that we have here in this fume hood once we're done working with the experiment. You've got inorganic waste here. Inorganic waste is going to be anything that doesn't contain carbon. So any salts or metals that you're working with, they're going to want to go in the inorganic waste. Here, somebody in the lab was working with naphthalene. Naphthalene is just a specific compound, and we have our own specific bottle for it. And then we have organic waste over here. So our organic waste is going to be anything that contains carbon. We sometimes also have a bottle in here for halogenated organic waste, and those are going to be organic compounds with carbon as well as halogens, and we'll talk about halogens later this year. So we got a few more things that you are going to want to do in the lab. Another one that you're going to want to do at the lab is as soon as you're done working with the substance in that bottle, you want to immediately put the cap back on there. What that's going to do is prevent any spilling. So if you accidentally bump it with your elbow and it knocks down, it's not going to just spill all over unless it shatters the bottle. So you got a little protection there. You're also protecting the bottle again from that contamination. You don't want anything getting into that bottle to affect the next experiment. So you want to immediately close up that bottle. And the last reason mainly is going to be for fire hazard. If you're working with a burner and you've got potential flammable liquid, maybe you're looking for the boiling point of that liquid, you don't want to have that open container full of that flammable liquid near the burner to begin with, as well as if it happened to be near the burner, you want that thing closed up tight so that the fumes, the volatile fumes, aren't getting near that open flame. Another really important thing is when you're working with glassware. Glass, whether it's room temperature, cold, or hot, unless it's glowing red hot, it's all going to look like the same glassware. So what you're going to need to do is check the glassware before you approach it. And the way you properly approach it is with the back of your hand. The reason we do that is we don't have as much callousing on the back of our hand so that we can approach that hot object, feel if it's dissipating any heat. If you don't really feel too much heat, you can give it a light tap with the back of your hand. If it's still not so hot, then you can probably just pick it up and move it after that. The next thing is going to be being careful when you work with sharp objects, particularly if you break some glass. Again, make sure you let your instructor know immediately so that they can help you clean the glass up. You may need to use scissors. You may need to use a syringe in your chemistry lab to dispense of some small items. We definitely use a syringe to dispense dimethyl sulfoxide in a lab that we do here, as well as any scalpels. Make sure you're taking the proper precautions when working with really sharp objects, and make sure you're not running around. Make sure you're not, pointing those towards yourselves or other people. Let them sit on the bench if you're not using them, and only pick them up and use them when you're absolutely sure that you're going to be safe and calm when you do these. One more thing before we take another tour around the lab is make sure that you guys read your pre-lab. The pre-lab is there for your benefit. It's got a nice introduction. It's going to tell you all of the equipment and materials that you're going to need to do the lab. You need to be thoroughly understanding your pre-lab before you even start coming into the lab and touching a bunch of stuff. I know where I went to university, if you didn't come in with your pre-lab, they would just kick you right out of the lab, and you couldn't even do the lab. So you got to make sure you're reading ahead of time. And all my students, when we're in the lab, they need to show me that they've written up an introduction, materials and methods, and they thoroughly understand what they're going to do before they even get into the lab and start touching stuff. All right, so let's take one more tour around the lab, and then we'll get on the whiteboard and look at these different symbols. All right, so the couple protective equipment things we have here. The first one we have here is called a fire blanket. So you're probably taught when you were young to stop, drop, and roll if you catch on fire. Well, this thing is going to be even a little bit better than that. It's very easy to use. Hopefully you don't catch on fire in the lab. If you do, hopefully you remember to go over to the fire blanket where the instructor will help you direct them to the fire blanket. So it's literally a blanket in here. It's got a little strap. It opens right up. There's a blanket inside of there. And so what you would do is you would rip the cord and you'd roll yourself up like a burrito. And that's going to extinguish the fire. All right, the next thing that we have here is our eye wash station. The eye wash station you probably won't be needing because you're going to be coming to lab every time with your goggles, right? But in that rare circumstance, something gets under your goggles, something crazy happens in the lab, you know. What you're going to do is use the eye wash station. There's all different eye wash stations. In this case, you literally just pull this thing down, and when you pull it down, the water begins to engage, and you're going to want to stare right into that water for about 15 minutes while the instructor calls 911 and the poison control, and you're going to want to flush those eyes out as much as possible. The next thing we have here that I've never had to use, I never want to use, I never want to see any student use, is the emergency shower. This works very similarly. I'm not going to demonstrate this one for you, but you just pull the handle straight down, and we've got a shower right above us, and you're going to get all that toxic chemicals off of you. There's not going to be a drain underneath of you, so all the chemically contaminated water is going to go all over the floor. The reason for that is if you're covered with toxic chemicals, you don't want it to go down the drain and go down into the river or the ocean. You're going to want to collect all of that toxic chemical when the poison control and hazmat team gets you. The next thing we have over here is a bloodborne pathogen kit. This is to clean up any blood or any kind of bodily fluid spills that may happen in the lab. So it's going to contain some substances like gauze and anything, some bleach or some neutralizing solution to neutralize any bloodborne pathogens. Is going to be located right inside. All right, the last stop on this tour is here on this wall. Here we've got a first aid kit. So any kind of Band-Aids that you might need, gauze, tape, anything to treat a wound that may happen in the lab, you're going to have here. You're going to have an electrical shutoff button. So in most newer labs, they're going to become equipped with this. I'm definitely not going to put this one now so the video doesn't cut out. But all you would do is if there's an electrical hazard, electrical fire, all you do is just slam that button and it's going to cut the electricity to the entire room. The last one here I will toggle for you. It's the gas shutoff valve. So when we're ready to use the burner, we just pop this guy out of the wall. It's going to turn on the natural gas, the propane, so we can light our burners. If there's a problem or at the end of the day when everyone's out of the lab, I just go over here and just slam the button. So that's exactly what you would do for this electrical button. So if your instructor ever gets injured or there's ever a need for that, all you're going to want to do is slam these buttons down and it's going to cut off either the gas or the electricity. All right, some other things you may didn't notice on this door is the hazard diamond. And we're going to get on the whiteboard right now and start looking at the hazard diamond in the GHS pictograms. So here we are on the whiteboard. And as you can see, this is called a hazard diamond. And the hazard diamond has 4 main sections. On the left, you have the blue area of the diamond. And this is going to represent all the health hazards that a compound may have. And the values on all sections of this diamond go from 0 to 4. So 0 being the least hazardous and 4 being extremely hazardous, very deadly. So a health hazard, a 0, is it's not going to be any hazard at all. A 1 might be slightly hazardous. You would need to ingest a lot or get a lot on you for it to be hazardous. A 2 is you need to take even more precaution. 3 is extremely dangerous. And 4, acute amounts would be toxic and deadly. The top of the hazard diamond is the red area, and this represents the fire hazard. The fire hazard, again, goes from 0 to 4, 0 being not flammable at all, and 4 being extremely flammable. A value of a 1 is it's going to ignite at values above 200 degrees Fahrenheit. Level 2 is going to be below 200 degrees Fahrenheit, but above 100. Level 3 is going to be anything below 100 degrees Fahrenheit will catch fire. And then 4 is a very low flash point of below 73 degrees Fahrenheit. So it may spontaneously catch on fire. To the right, we have the yellow area of the hazard diamond. And this represents how stable the compound is or how reactive it is with other things. So at 0 value is an extremely stable compound. 1 is going to be unstable if it's at a very high temperature. 2 is going to be a violent chemical change at any temperature. 3 is going to be any shock or heat may cause this to explode. And 4, it just may spontaneously detonate. And a good example of this are ethers that are left on bench tops or in a fume hood. Particularly if they're old bottles of ethers, you don't want to disturb them because they may spontaneously explode. The bottom of the hazard diamond is for special symbols, particularly the ones listed here. You've got acid. If it's labeled acid, then it's going to be an acidic compound, so it's very easy. Alkali is labeled ALK, so this is going to be a very basic solution, and it's going to be corrosive. Something that may be not acid or a base, but it still may be corrosive is going to be labeled COR for corrosive. An oxidizer is something that's going to rip electrons from something else. Oxidation is a loss of electrons, so it's going to be able to rip electrons, and that usually dissipates a lot of energy, so it could release a lot of heat and energy. The radiation symbol, if you're familiar with the channel, that's going to be things that emit radioisotopes, so either a beta, alpha, or gamma emitter. And then this W with a slash through it is something you don't want to have water around. If we go now to look at the global harmonized pictograms, there are 9 of those. So here we've got our 9 globally harmonized pictograms. The first one in the top left is a health hazard. So it's got the dude in there with his chest kind of exploding. And this is going to represent anything that's a carcinogen, so it's going to cause cancer, a respiratory sensitizer, something that will affect your reproductive health, target specific organs, whether it be your liver, kidneys, any other type of organ, or a germ cell mutagen, so that would be targeting specifically sperm cells and egg cells that would affect your future children. The next one is flame. So flame is going to look like a fire, and this is going to be representative of things that are very flammable. So it's going to be flammable gas, liquid or solid. These can be self-reactive or pyrophosphoric, so anything that's going to be extremely flammable. The top right is going to be an exclamation mark, and that's going to represent irritant, a dermal sensitizer, or something that's acutely toxic or harmful. So you're going to see that exclamation mark. The middle left is a gas cylinder, so anything that is a compressed gas, like a big helium tank or something like that, a liquefied gas or something that has a lot of dissolved gases, these can be very hazardous. You typically chain gas cylinders to a bench or to the wall, and I have at my university seen that a gas cylinder fell, hit the regulator off, and you basically have a rocket, and this rocket went through cinder block walls. So you definitely want to be careful with compressed gas cylinders. They may explode or they may just take off if they're hit the right way. In the middle of the chart, we have things that are corrosive. And the symbol for this is either a bench top or a piece of metal getting drips on it. You could see steam or smoke coming up, or the guy's hand is also getting eaten away by this material. So this is going to cause skin corrosion, serious burns, or it's going to damage your eyes. But again, hopefully we're going to be wearing our goggles. In the far right of the middle, we've got exploding bomb, and it looks like this kind of sphere that's exploding apart. And this is going to be representative of something that's very explosive, something that will self-react, or an organic peroxide. And a peroxide is just something that has an oxygen bonded to another oxygen that's bridged to some other organic group, which we can represent as R. So this is called a peroxide bridge. If you've got flame over circle is going to represent oxidizer. So anything that's going to rip electrons off again, it could be an oxidizing gas, liquid, or solid. This would be an oxidizer. So these are also going to give you potential burns. The middle bottom is environmental toxicity. So you kind of see the dead fish floating upside down with the dead tree. That if these compounds get out into the environment, it's going to cause environmental damage, and it's going to cost a lot of money, and a lot of other organisms may die from this. And then things that are poisonous, the bottom right, you're going to see skull and crossbones. Any minute amount of this would be extremely toxic, potentially fatal. So now let's look at hazard diamond. So let's look at a compound that's used pretty often in the lab, and that's ethanol. So an ethanol example would be a 2 health hazard. So it's fairly hazardous in large quantities, though people consume ethanol. It's got a 3 fire hazard, so it's going to ignite below 100 degrees Fahrenheit. Anything above 50% ethanol is going to be very flammable. Though it's very stable, and you're not going to have anything in the white box. So here we've got an MSDS sheet for sodium hydroxide. So an MSDS sheet is a material safety data sheet, and if you're in the lab or working with compounds, you should have an MSDS sheet for every chemical that you have within the building. Section 1 is going to tell you the name of the product, catalog numbers, what other people call this, because Earth is very big, so people call it different things, depending on what area of the country or different country you're in, how we use it, and how you shouldn't use it. So you're going to notice a lot of these future sections of the MSDS sheet are very repetitive. So the things that you're really looking for on your MSDS sheet is what the hazards are and how you should deal with those hazards, as well as any physical properties of the compound. So hazard identification is going to be the second category here, and this is going to tell you what category this falls under the OSHA standards, and this is what we follow in the US. So this is a category 1 corrosive to metal, category 1 corrosive to skin and eyes, and a category 3 for target organ toxicity. You've got certain keywords that you'll need to know. So in this one, the signal word is danger. And the hazard statements are it's corrosive, which we just read, and it could potentially burn your eyes and your skin, as well as it may cause respiratory irritation. If we look down here we've got some of our GHS symbols. We've got the exclamation part, which is showing us that we need to be careful about this, and then we've got the corrosive diamond showing that it's going to corrode us. The prevention is we shouldn't breathe this, dust, fumes, gas, mist, vapor, spray of any of this sodium hydroxide. You don't want to get it on you. You want to wash your face if it gets on you, your hands, any exposed skin, wear your PPE like I showed you earlier in this video, wear your eye protection, wear your gloves. You want to do this under a fume hood or do it outside if you're going to use this, as well as keep only in the original container. You don't want a secondary container. Don't take pellets of the sodium hydroxide and put it in a soda bottle. Don't ever do something like that. This also tells you what you should do in response to any of these things. You should call the Poison Control Center as well as the doctor and physician, as well as you should immediately contact your supervisor of the lab or your instructor. If you inhale it, it's going to tell you you need to get the person to fresh air, position them in a comfortable position. Skin, take off all the clothing, rinse the skin off. Eyes, you should be wearing your goggles, but if something happens, you need to go to the eye wash station, rinse it for 15 minutes while the instructor calls the doctor. Ingestion, you're going to want to rinse the mouth out. You do not want to induce vomiting because you don't want that burning stuff to come back up through the esophagus as well as going down. You don't want it to go both directions. Spills, it'll tell you that you need to absorb the spillage and then you're going to dispose of it properly in the proper container. And then how to properly store it. I'm going to show you storage containers at the end of the video. You need to put this under a hood, put it in a polypropylene bottle, store this in a dry place. The next one is how this is composed. So section 3 is a very short one. It's just going to tell you what's in the bottle. Section 4, we're kind of repeating ourselves again. This is the first aid measures, what you need to do, general advice, whether it contacts your eye, contacts your skin, whether you inhale it, whether you ingest it, the important symptoms of what's going to happen if you're exposed to this, and then what you're going to need to tell the physician. The next area, section 5, is how flammable it is. Sodium hydroxide crystals are not flammable at all, so it's a value of 0 on that 0 to 4. And if you look at the bottom here, the NFPA, those are the values that are going to go on the hazard diamond. It would be blue 3, flammability red 0, instability yellow is a 1, so it's slightly unstable. You wouldn't want to react this with any acids. Other than that, it's not very flammable. Number 6 is what's going to happen if you accidentally release this. And again, it's just very repetitive. You want to get it off your skin, take the clothes off, call the doctor. How to clean it up. Handling and storage, you're going to keep these in the fume hood or in a proper cabinet, and you need to keep it cold and dry, or cool and dry. Number 8 is exposure controls of what is the acceptable limits of exposure within that specific lab you're in. And each country is going to have different standards. We follow OSHA primarily in the US. Engineering measures are what kind of tools you need to limit that exposure. So wear your PPE, cover yourself with the lab coat or whatever necessary supplies, wear your goggles, and follow all your hygiene measures. Section 9 is all the physical properties. So in this case, it's being sold as a liquid. The liquid's clear, it doesn't smell. This is going to tell you the pH, the melting point, the boiling point, whether it's got a flash point, whether it's flammable, the vapor pressure, specific gravity. All the physical characteristics are going to be found in Section 9. Section 10 is how stable it is and how reactive it is with other things. So it's stable under normal storage conditions. You don't want to have this with acids, organic materials, or metals because it's going to be corrosive, as well as it could be hazardous to the polymerization. It's going to be hazardous polymerization does not occur. So it's safe to store in plastic bottles. Number 11 is what the toxicological information is. So how much it would need to cause you to die. And unfortunately, we use animals to do this. Animal testing is pretty much done with all compounds. The LD50 oral dose is how much it took to kill 50% of the rats that they treated, and it was a range of 140 to 340 milligrams per kilogram of rat. LD50 dermal is how much you would need to be exposing on your skin, and they used a rabbit for this. So it took 1,350 milligrams per kilogram exposed to that rabbit skin to kill 50% of the rabbits. And there's not many developmental effects from this, mutagenic effects. We don't have any information on this MSDS sheet. Symptoms, again, it's repetitive. It's going to burn you. If you swallow it, it's going to hurt your esophagus, your stomach, cause indigestion, swelling, skin scarring, these other things. And environmental information is going to be Section 12. This is going to tell you what's going to happen, how you should dispose of it. Don't put it down the drain. Large amounts will affect the pH of the environment and cause aquatic harm. It's harmful to aquatic organisms. Freshwater fish is going to tell you the lethal concentration, which was 45.4 milligrams per liter within this specific pond example. 13 is how you should dispose of it. We already looked at all the different waste bottles, and your instructor will tell you how to dispose of every chemical. 14, you won't really be transporting any chemicals around, so you don't need to worry about that. That's people who use trucks to move these around. 15 is any regulatory information from each country. And 16 is any other relevant information that you may need. So that's pretty much everything on the whiteboard. All right, so I'm going to quickly take you guys into the prep room to show you how we store properly all of these chemicals. So let's look right here. What we got here is our flammable cabinet. So all of these cabinets down this row are all yellow, and that's representative of flammable compounds. So anything that gets flammable, we keep it tucked away so that the vapors can't be near any sparks and cause an explosion. So they're all labeled flammable, and they're all yellow. So we go down here. We've got the poisons. The poisons have a skull and crossbone on them to let you know that they're very poisonous. So any toxic compounds are going to be located in these cabinets that we've got stacked on top of each other. All of the corrosive cabinets are going to be labeled in blue. So all of the bases typically, like sodium hydroxide, all the hydroxides, potassium hydroxide, ammonium hydroxide, these are all going to be in the blue cabinet labeled corrosives. All right, if we bring you over here, we've got the light blue cabinet labeled acids. So a lot of the common acids, acetic acid, carbonic acid, the weaker acids are going to be in the acid cabinet. We don't want them to be near the corrosive base cabinet because they will react, and we don't want that. We need to store these properly. For nitric acid and sulfuric acid, we have our own special acid cabinets so that these very strong reactive acids are located separate from one another in their own special cabinet. And lastly, we'll just look down. All of these chemical compounds are stored properly onto shelves that are inorganic or organics, and they all have their own special shelf so that they don't react with one another. So we need to keep everything based on the MSDS sheet away from one another and on their particular shelf. So there it is, you guys. If you found this useful, subscribe, smash the like button. Let's get this chemistry content to the top of the YouTube algorithm, and we'll see you in the next video, which is going to be lab equipment.